The name of this topic is Arithmetic and Geometric Sequences, Identifying and Writing an Explicit Rule. So what we're given here is two sequences. For each one, we have to determine whether it's arithmetic sequence or geometric sequence. Then once we do that, we have to fill in the formula to get to the nth term. So how you know the difference between the two is this. If the sequence is a pattern of something that's being continually added or subtracted, because that's just like adding the opposite, that's an arithmetic sequence. A geometric sequence would be a sequence, a pattern, where the numbers were being repeatedly multiplied by the same number. So let's do this one first. -6, -24, -96. That's being repeatedly multiplied by 4, so I know that's going to be a geometric sequence. This one, going from -11 to -9 to -7, is being repeatedly added, so I know that's an arithmetic sequence. This one's geometric, this one's arithmetic. So how you solve these would look like this. Now we know what they are. Now we have to plug what we can into the formulas to solve them. When you click the Explain tab on this topic, it can look overwhelming because Alex takes a while to prove to you why the formula will work. So if you just cut to the chase, here's the formula for the arithmetic sequence, and we can plug in the numbers we have to solve it. Here's the formula for the geometric sequence. So we identified earlier that this sequence, -6, -24, and -96, is geometric because it's being repeatedly multiplied by 4. So when we plug it into this formula, which is the formula for a geometric sequence, the answer will be equal to A1, which is the first term. Well, we know what the first term is. That was -6. Times the common ratio. That we know because we could tell it's being repeatedly multiplied by 4, so that will go in place of 4. N we can't solve because N is the number of the term that you're looking for, and it's not specified how high we're supposed to go in the sequence, so we don't know what N is worth. So when we solve it, this is as far as we can go before we have to quit. We can put -6 in place of this, 4 in place of this. We don't know what N is, so now we're stuck. We can't solve it any further, and we can't simplify this any further. The other sequence that was -11, -9, -7, we determined was arithmetic because it was repeatedly adding 2. So when we plug it into the formula, which is here for the arithmetic sequence, here's what we know. A subscript 1 is the first term. Okay, that's -11. That's the first term we were given. Plus N. N is the number of the term that we're looking for. That's not specified, so we don't know that. -1 times the common difference. Well, the common difference between these is 2. So we'll plug in what we know. -11 plus N minus 1 times 2. Now by order of operations, we would do inside the parentheses first, but we can't because we don't know what N is worth. But we can multiply 2 times both of these. So then we would take 2 times -1 and get this -2. 2 times N, we can put that here. We'll just recopy the -11. Now finally in this row, what we want to do is collect any like terms that we have. Well, -11 minus 2, we can do that. That math we can do. A -11 minus 2 will be a -13. The 2n we can't do anything with but recopy, so that will be the answer. So then when you type it in, you would type in 2n minus 13 for the formula. And that is how you solve arithmetic and geometric sequences, identifying and writing an explicit rule.